Good morning. I am Subbulakshmi, Department of Mechanical Engineering. I am going to present the topic Working Principle of Centrifugal Pumps. Centrifugal pumps are the mechanical energy of motor is converted into pressure energy by means of centrifugal force acting on the fluid. So this is the construction of centrifugal pump. There are main parts of centrifugal pumps are impeller, suction pipe with foot valve and casing. Impeller, outer part of the impeller is casing and delivery pipe. These are the main parts of centrifugal pump. So the components of centrifugal pumps are impeller, casing, suction pipe, delivery pipe, foot valve, strainer. Impeller is the rotating part of the centrifugal pump. A wheel with series of backward curved vanes is called as impeller. Casing is a airtight chamber surrounding the impeller. So the suction pipe is one end of the pipe is connected to the eye end of the impeller, and the other end is dipped in a liquid, that is in a sump of the centrifugal pump. Delivery pipe, here one end of the pipe is connected to the eye end of the impeller and the other end is to overhead tank. And also the foot valve is the main part of the centrifugal pump. It allows water only in upward direction. Then last part is strainer. It prevents the entry of foreign particles, that is dust, impurities, other materials present in the water. Now we see about working of centrifugal pump. When a certain mass of liquid is rotated by an external source, it is thrown away from the central axis of rotation and centrifugal head is impressed, which enables it to rise a higher level. The delivery valve is closed and pump is primed, that is suction pipe, casing and portion of delivery pipe up to delivery valve are completely filled with water so that no air packet is left. So keeping the delivery valve is closed, the impeller is rotated by motor. A strong suction is created at the eye of the impeller. So here impeller action develops pressure energy as well as velocity energy. So water is lifted through a delivery pipe up to required height. When pump is stopped, delivery valve should be closed to prevent backflow from reservoir. This is the working of centrifugal pump. There are many types of casing. Three types of casing: volute casing, vortex casing, casing with guide blades. First type is volute casing. Here only impeller is placed in the casing. That is called as volute casing. Volute casing, here area of flow gradually increases from the eye of the impeller to the delivery pipe, same as it is shown in the figure. So in vortex casing, a circular chamber is provided between the impeller and volute chamber. This is the difference between volute casing and vortex casing. So here loss of energy due to formation of eddies is reduced. Thus the efficiency of vortex casing is greater than the volute casing. Casing with guide blades. Here, casing impeller is surrounded by a series of guide vanes which is mounted on a ring which is known as diffuser. So, water enters the impeller without shock. So, eddy formation is reduced. So, efficiency is increased always. Then third casing type is casing with guide blades. Here impeller and also guide vanes are surround the impellers. This is called as casing with guide blades. The impeller is surrounded by a series of guide blades mounted by a ring which is known as diffuser. The guide vanes are designed in such a way that the water from the impeller enters the guide vanes without shock. Also, the area of guide vanes increases, thus the reducing the velocity of flow through the guide vanes and consequently increasing the pressure of the water. So, this is one of the main important part of centrifugal pump, casing with guide blades. Now, we will see about various types of heads of centrifugal pump. Here, suction head. Suction head means from the free surface of the liquid, then the eye of the impeller, the distance between the distance is called as suction head. From eye of the impeller and delivery pipe, the distance is called as delivery head. So, suction head and delivery head and manometric head and static head. There are 4 types of heads in centrifugal pump: suction head, delivery head, static head, manometric head. Suction head is nothing but the distance of amount of water to be lifted, that is called as head. So, suction head, it is a vertical distance between the level of sump and eye of the impeller. It is also called as suction lift. Delivery head, it is the vertical distance between eye of an impeller and the level at which water is delivered to the delivery pipe, that is called as delivery head. Then static head, it is the sum of suction head and delivery head. It is so total of suction head, delivery head is called as static head. Manometric head is the head against which the centrifugal pump has to work is called as manometric head. Here now we face the problem of centrifugal pump is cavitation. What is cavitation? Whenever the pressure in the pipe falls below the vapor pressure corresponding to the existing temperature of the liquid will vaporize and bubbles are formed and collapses. In this process continued rapidly and creates high pressure which can damage the impeller. So, this phenomenon is known as cavitation. So, bubbles are formed inside the pipe, that is known as cavitation. So, the cavitation is generally occurs in centrifugal pumps near the inlet of the impeller. This is the main problem occurs in centrifugal pump. What is the effect of cavitation? It is an undesirable one. It is following the disadvantages. The large number of vapor bubbles formed are carried with the liquid. A high pressure region is reached where these bubbles suddenly collapse. This includes the rush of surrounding liquid and produces shock and noise. This phenomenon is known as water hammer. So, the second point of disadvantage is the surface of blades and impeller are worn out. That is corroded because of bursting of bubbles. The water hammer phenomenon is fatigue for the metal parts and it reduces the life by blow action. Next we will see about reciprocating pump. The reciprocating pump is a positive displacement pump. It is a positive displacement pump where certain volume of liquid is collected in enclosed volume and discharged using pressure to the required application. These pumps are more suitable for low volumes of flow at high pressure. These are the components of reciprocating pump. Here a cylinder with piston is connected, one end of the connecting rod and the other end of the crank is rotating at the other end of the connecting rod. Here suction pipe and delivery pipe also there. This is the components of reciprocating pump. So, what are the main parts of reciprocating pump is suction pipe and delivery pipe, cylinder with piston and connecting rod, a crank is rotating. These are the main parts of reciprocating pump. So, the main components of reciprocating pump are suction valve, delivery pipe, delivery valve, cylinder, piston and piston rod, crank and connecting rod, strainer, air vessel. Suction pipe. Suction pipe connects the source of liquid to the cylinder of the reciprocating pump. The liquid is sucked by this pipe from the source to the cylinder. Suction valve. It is a non-return valve, which means only one directional flow is possible in this type of valve. This is placed between suction pipe, inlet and a cylinder. During suction of liquid, it is opened, and during discharge, it is closed. Delivery pipe. Delivery pipe connects cylinder of pump to the outlet source. The liquid is delivered to desired outlet location through this pipe. Delivery valve. Delivery valve also non-return valve placed between cylinder and the delivery pipe outlet. It is closed position during suction and is opened position during discharging of liquid. Cylinder. A hollow cylinder made up of steel, alloy or cast iron. Arrangement of piston and piston rod is inside the cylinder. Suction and release of liquid takes place in this. So both suction and delivery pipes along with valves are connected to this cylinder. Piston and piston rod. Piston is a solid type cylinder part which moves backward and forward inside the hollow cylinder to perform suction and deliverance of liquid. Piston rod helps the piston to its linear motion. Then crank and connecting rod. Crank is a solid circular disc which is connected to the power source like motor, engine, etc. for its rotation. So connecting rod connects the crank to the piston. As a result, the rotational motion of crank gets converted into linear motion of the piston. Strainer. Strainer is provided at the end of the suction pipe to prevent the entrance of solid particles from water source into the cylinder. Air vessel. The main part of the reciprocating pump is air vessel. Here the air vessel, the suction pipe, suction valve is the air vessel of suction side and another air vessel of delivery side. Air vessels are connected to both suction and delivery pipes to eliminate the frictional head and to give uniform discharge rate. So continuous flow of water. In order to getting continuous flow of water, air vessel is provided in the reciprocating pump. This is one of the main advantage of reciprocating pump. Then we will see about working of reciprocating pump. When the power source is connected to crank, the crank will start rotating and the connecting rod also displaced along with crank. Then the piston connected to the connecting rod will move in linear direction. If crank moves outwards, then the piston moves towards its right and creates vacuum in the cylinder. This vacuum causes suction valve to open and the liquid from the source is forcibly sucked by the suction pipe into the cylinder. When the crank moves inwards to outwards the cylinder, the piston will move towards left and compresses the liquid in the cylinder. Now the pressure makes the delivery valve to open and the liquid will discharge through the delivery pipe. When piston reaches its extreme left position, the whole liquid present in the cylinder is delivered through the delivery valve. Then again the crank rotates outwards and piston moves right to create suction and whole process is repeated. Generally, the above process can be observed in a single acting reciprocating pump where there is only one delivery stroke per one revolution of crank. But when it comes to double acting reciprocating pump, there will be two delivery strokes for one revolution of crank. Here it is a use of reciprocating pump. Reciprocating pump is mainly used for oil drilling operations, pneumatic pressure systems, light oil pumping. Next we will see about hydraulic machines. Hydraulic machines, here previously we see about turbine pumps. Here is a turbines. Hydraulic machines are pumps and also turbines. Pumps, which is hydraulic mechanical energy is converted to hydraulic energy, which is called as pumps. Here turbines which hydraulic energy is converted into mechanical energy. That is a reverse of the pumps is called as turbines. Here turbine is a rotating mechanical device that extracts energy from fast moving flow of water, steam, gas, air and other fluid and converts into useful work. So the hydraulic energy of water is used in the used is the inlet of the turbine. It consists of moving part called rotor assembly, which is shaft or drum with blades are attached. There are the various classification of turbines. First one is according to the type of energy available at the inlet of the turbine. First one is impulse turbine and reaction turbine. Impulse turbine, here water possesses only kinetic energy. And also reaction turbine, water possesses both kinetic energy as well as pressure energy. According to the direction of flow of water, tangential flow, radial flow, axial flow and mixed flow. In tangential flow, water enters the tangent to the runner. Radial flow, the water enters the radial direction of the runner, it is called as radial flow. Axial flow means water enters directly axially and leave it to the radially, it is called as axial flow turbine. Mixed flow in this water enters radially and leaves axially, another words conversely, water enters axially and leaves radially, also called as mixed flow type of turbine. According to the available head at the inlet of the turbine, high head turbine, medium head turbine and low head turbine. And last one we will classify as according to the specific speed of the turbine, low specific speed of turbine, medium specific speed and high specific speed. So already we see about impulse turbine. Here which is driven water possesses only kinetic energy, that is known as impulse turbine. Example is Pelton turbine, which is which is driven by high velocity jet of water. High velocity jet of water is just called as impulse turbine. In reaction turbine, the rotor of a reaction turbine is fully immersed in water and enclosed in a pressure casing. So pressure is created. The runner blades are profiled so that pressure differences across them impose lift forces, just as in aircraft wings, which will cause the runner to rotate faster than is possible, which is a jet. Example is Francis turbine. According to the flow of water, a tangential flow turbine is called as Pelton wheel turbine. And radial flow, the example of radial flow turbine is modern Francis turbine. There are other two types of radial flow turbine, inward radial flow turbine, outward radial flow turbine and mixed flow radial turbine. And the last one is axial flow turbine. The example of axial flow turbine is Kaplan turbine. In impulse turbine, the parts of impulse turbine, that is Pelton wheel turbine, first part is nozzle and flow regulating arrangement, and runner with second part runner and buckets, third one is casing, fourth one is braking jet. The first one is nozzle and flow regulating arrangement. Here the sphere is a conical needle which is operated by hand wheel or either motor. The amount of water striking the runner is controlled by providing the sphere in the nozzle. If the sphere is moved in the forward direction, water is reduced, and also the sphere is moved from backward direction, water is increased. So this is the nozzle and flow regulating arrangement. In order to sphere movement in the forward direction, water is reduced. The runner is also the next main part of Pelton wheel turbine is runner with vanes. Here a circular disc on the periphery of which a number of buckets evenly spaced, that is constant space and fixed. The shape of the bucket is of double hemispherical cup or bowl shape. Each bucket is divided into two symmetrical parts by dividing wall. It is known as splitter. Casing. The function of casing is the outer part of the impeller. The function of casing is to prevent the splashing of water and discharge the water to tailways. It acts as a safeguard against accidents. It is also made up of cast iron or fabricated steel parts. There is no any hydraulic function of casing in this Pelton wheel turbine. Braking jet. When the nozzle is completely closed, that is when the sphere is moved forward direction, the amount of water is reduced to zero. It is closed by moving sphere in the forward direction, the amount of water is reduces to zero. Due to inertia, the runner goes on revolving for a long time. In order to stop the runner, so a small nozzle is provided which directs the jet of water on back of vanes. This is called as braking jet. It is a amount of water against, it is the amount of water flow along the direction. Braking jet. When the nozzle is completely closed by moving sphere in the forward direction, the amount of water striking the runner reduces to zero. Due to inertia, the runner goes on revolving for a long time. To stop the runner, a small nozzle is provided which directs the jet of water and back of vanes. Now we will see about working principle of Pelton wheel turbine. When the fluid strikes the blades of the turbine, the blades are displaced, that is rotated, which produces rotation energy. When the turbine shaft is directly coupled to an electric generator, mechanical energy is converted to electric energy. This electrical power is known as hydroelectric power. This is the working principle of Pelton wheel turbine. Here, along the runner, a casing is provided. Water is flowed tangential to the runner. So, it is called as the tangential flow turbine. So, also Pelton wheel turbine. Pelton wheel turbine is a tangential flow turbine. The working of Pelton wheel turbine. As the water jet hit the bucket blades, the direction of water velocity is changed to follow the contours of the bucket. Water impulse energy exerts a torque on the bucket and wheel system, spinning the wheel. The water stream itself does a U-turn and exits at the outer sides of the bucket. So, Pelton wheel operates best with height of 50 to 2000 meter and flow rate is very low, 4 to 15 meter cube per second. So, it is suitable for high head and low flow rate type of turbine. Applications. Pelton wheels are preferred in turbine for hydropower. When available water sources has relatively high hydraulic head at low flow rates. Pelton wheels are made in all sizes for maximum power and efficiency. The wheel and turbine system is designed such that the water jet velocity is twice the velocity of the rotating buckets. There exist in multi-turn Pelton wheels mounted on vertical oil pad bearing in hydroelectric power. Next we will see about Francis turbine. It is a reaction type of turbine. The parts of Francis turbines: volute casing, fluid impeller, guide vanes, runner with blades. Working of Francis turbine. In the Francis turbines, the water must be entered into the inlet nozzle and the velocity must be decreases. Then the water moves in the forward direction in the turbine, but continuous decrease in spiral casing area must be happened. So with the constant speed, the water strikes the turbine blades. On the runner, the blades are mounted. The blades are designed like a thin aerofoil. So, due to the design, the water flow occurs at low pressure at one point and the other side creates a low pressure. So, the motion takes place from the high pressure to the low pressure. Inside the blade, it looks like a bucket. It using the impulsive force for rotation of water. If the flow rate of water changes, then by using the governing mechanism, we can set the angle of attack of the water on the blade. At that case, the turbine works properly. Initially, the water passes from the blades and later enters into the draft tube, where we can notice the continuous increment in the area and velocity of the water must be decreases. So it is suitable for medium head of turbine, that is 45 meter to 250 meter. It is also called as reaction turbine. Here water possesses only both kinetic energy as well as pressure energy. So it is called as reaction turbine. The flow of turbine is mixed flow. Water flows radially and leaves axially. Medium specific speed. The specific speed range is 50 to 250 rpm. Then the disposition of shaft of runner is vertical. That is the shaft position is vertical. Here penstock. Penstock is a large size conduit which conveys water from upstream to the dam or reservoir to the turbine runner. Spiral casing. It constitutes a closed passage whose cross section area gradually decreases along flow direction. Area is maximum at inlet and nearly zero at exit. So guide vanes. Another part of the turbine is guide vanes. These vanes direct the water on the runner at an angle appropriate to the design, controlled by hand wheel or governor. This is the main mechanism used in this. Governing mechanism is very important. That is, it changes the position of guide vanes to affect a variation in water flow rate when the load condition of turbine changes. The runner blades. The driving force on the runner is both due to impulse force and reaction effect. Usually runner blades are 16, the number of runner blades are 16 to 24 is placed in the impeller. Draft tube. It is generally an expanding, it is a gradually increasing area of the tube which is used to discharge water from water to the tail race. So draft tube is used in the only for reaction turbine. It is not used in the Pelton wheel turbine, that is tangential flow turbine, impulse turbine. So draft tube, it is a main part of the turbine. Draft tube is a tube of decreasing cross section area and it delivers to the water with the tail race. When the pressure of water is decreasing, it increases the pressure and delivers it to the tail race. So what are the efficiencies? That is, efficiencies used in the turbines are hydraulic efficiency, mechanical efficiency, volumetric efficiency and overall efficiency. First we see about hydraulic efficiency. Hydraulic efficiency is the ratio of power developed by the runner of a turbine to the power supplied by the water at the inlet of the turbine. This ratio is called as hydraulic efficiency. So hydraulic efficiency, which is denoted by eta H. Eta H is equal to power developed by the runner divided by power available at the inlet of the turbine. Then we will see about mechanical efficiency. It is the ratio of power available in the shaft of the turbine to power developed at the runner. So mechanical efficiency is denoted by eta M. Eta M is equal to power at the shaft of the turbine to power developed by the runner. Then volumetric efficiency. Volumetric efficiency is the ratio of volume of the water actually striking the runner to the volume of water supplied to the turbine. So it is denoted by eta V, that is volume of water striking the bucket to the volume of water supplied to the turbine. Then overall efficiency. It is the power of available at the shaft of the turbine to the power supplied by the water at the inlet of the turbine. So overall efficiency is denoted by eta O, that is equal to power available to the shaft divided by power available to the inlet. In order to overall efficiency also denoted by, overall efficiency is the multiplication of volumetric efficiency, mechanical efficiency into hydraulic efficiency. The application of Francis turbine. The Francis turbines are primarily used for producing electricity. Both Pelton wheel turbine also Francis turbine. The power output of the electric generators generally ranges from just few kilowatts up to 1000 megawatts through many 1000 megawatts. The head against the Francis turbine is 100 to 300 meters. That is medium head. Thank you.